In the ongoing quest for sustainable energy solutions, we often find ourselves at the crossroads of innovation and necessity. As fossil fuels dwindle and the demand for clean energy intensifies, the world is turning its attention to renewable alternatives. Among these, one source stands out as a beacon of promise: geothermal energy. Join us as we delve deep into the world of geothermal power, exploring its untapped potential, innovative applications, and the groundbreaking advancements that are making it a game-changer in the global energy market. The sun may be the most popular star in our sky, but here on Earth, there's another star that holds even more fascination, the one beneath our feet, our very own sun. If you think I'm talking about a massive ball of burning gas millions of miles away, think again. I'm referring to the core of the Earth, a place of unimaginable heat and pressure. The Earth's core reaches temperatures of over 9,000 degrees Fahrenheit, hotter than the sun's surface. This intense heat has the potential to fuel our world, providing an almost limitless supply of energy if we can tap into it. But how? That's where the brilliance of human ingenuity comes into play. By drilling deep into the Earth, we can access this subterranean furnace and harness its power through geothermal energy. Harnessing the Earth's internal heat has long been a dream, dating back to the ancient Greeks, who first noted the warm springs bubbling to the surface. They recognized the presence of geothermal energy, though they couldn't comprehend its true potential. Fast forward to modern times, and we're making giant strides in unlocking this potential. The United States leads the way with the world's largest geothermal plant, the Geysers, located in Northern California. Covering an area larger than Manhattan, this geothermal wonderland produces enough electricity to power over 1 million homes annually. Impressive, isn't it? But that's just the beginning. Iceland, a country sitting on the top of the mid-Atlantic ridge, a major tectonic plate boundary, is a geothermal powerhouse. Approximately 89% of Icelandic families use geothermal for heating, significantly reducing their reliance on fossil fuels. In places like Kenya, geothermal energy is bridging the gap between rural communities and electricity access. The Olkaria geothermal plant provides much-needed power to over 100,000 households. And the best part, it's carbon neutral, ensuring a cleaner future for generations to come. Geothermal energy is derived from the Earth's internal heat, a virtually inexhaustible resource generated by the planet's core. It's a testament to the Earth's natural processes that have been occurring for billions of years. This heat originates from the formation of the Earth, the decay of radioactive elements within its core, and the remnants of heat left over from its early formation. As a result, the Earth's interior is a hot, dense mass with temperatures increasing with depth. These high temperatures create immense pressure, causing water in the Earth's crust to turn into steam. When this steam reaches the Earth's surface, it forms what we know as geothermal energy. But accessing this energy isn't a simple task. It requires drilling deep into the Earth, sometimes as much as 6 kilometers below the surface, to reach temperatures suitable for power generation. Geothermal energy is extracted through wells that tap into these underground reservoirs of hot water or steam. The energy contained in the steam is then converted into electricity using conventional power plant technology. This process is highly efficient and environmentally friendly when compared to traditional fossil fuel power plants. One of the significant advantages of geothermal energy is its renewability. Unlike fossil fuels, which are formed over millions of years, geothermal energy is continuously replenished as the Earth's core remains hot and water naturally circulates through the crust. This means that geothermal energy can be used indefinitely without depleting the resource. Furthermore, geothermal power plants have a small land footprint, meaning they occupy a relatively small area compared to other energy generation methods. They also produce minimal greenhouse gas emissions, contributing to a cleaner environment. Despite these advantages, there are challenges associated with geothermal energy. One major issue is the high cost of drilling and maintaining wells, especially when tapping into deep reservoirs. Additionally, geothermal energy is not available everywhere and can vary greatly from region to region. However, with technological advancements and increased investment in geothermal research, Many of these challenges are being overcome. New techniques such as enhanced geothermal systems are expanding the potential for geothermal energy production by targeting hotter, deeper rocks. As we continue to explore and understand the Earth's internal energy, we unlock new possibilities for sustainable power generation. Now, let's talk about the costs involved in generating 1 megawatt of electricity using various energy sources. It's important to note that these figures are approximate and can vary based on factors such as location, technology, and resource availability. Coal, a widely used fossil fuel, costs approximately $243 per megawatt hour to generate electricity. Natural gas, another fossil fuel, is slightly more expensive at around $367 per megawatt hour. Nuclear power, on the other hand, is significantly more costly at $532 per megawatt hour. On the renewable side, hydropower is relatively inexpensive at $47 per megawatt hour. Wind energy costs around $40 per megawatt hour, while solar photovoltaic systems range from $50 to $100 per megawatt hour, depending on factors such as sunlight availability. Geothermal energy falls within a similar range to solar and wind, costing roughly $50 to $100 per megawatt hour. This cost can vary based on factors such as the depth of the geothermal reservoir and the cost of drilling. When considering the cost of electricity generation, it's crucial to factor in not only the initial investment, but also the ongoing maintenance and environmental impacts. While fossil fuels have historically been the dominant source of electricity, their costs are expected to rise due to resource depletion and environmental concerns. Renewable energy sources like geothermal offer a promising alternative with potentially lower costs and a smaller carbon footprint. The cost of electricity generation using geothermal energy is influenced by several factors, including the depth of the geothermal reservoir, the cost of drilling, and the efficiency of the power plant. In areas with shallow, low-temperature geothermal resources, the cost of electricity generation can be higher due to the need for more wells and surface facilities. Conversely, in areas with deep, high-temperature geothermal reservoirs, the cost can be significantly lower as fewer wells are required. Technological advancements in drilling techniques and power plant efficiency can also impact the overall cost. As with any energy source, the cost of electricity generation using geothermal energy is subject to market fluctuations and government policies. For example, government incentives and carbon pricing mechanisms can influence the cost by making geothermal energy more or less financially attractive. There are several ways in which geothermal energy can contribute to a sustainable future. Firstly, it offers a clean and renewable energy source. Unlike fossil fuels, geothermal energy does not produce greenhouse gases during operation, reducing the carbon footprint of electricity generation. This is particularly important in mitigating climate change and reducing air pollution. Secondly, geothermal energy is a reliable and consistent energy source, unlike solar and wind energy, which depend on weather conditions. Geothermal power plants can operate continuously, providing a stable baseload power supply. This reliability is essential for critical infrastructure and can help reduce the intermittency issues associated with renewable energy. Thirdly, geothermal energy can be used for direct heating and cooling purposes, reducing the need for fossil fuel-based heating systems. In areas where geothermal resources are readily available, this can significantly reduce energy costs and greenhouse gas emissions in buildings and industrial processes. Lastly, geothermal energy can contribute to energy independence and security by providing a domestic source of renewable energy. Countries that rely heavily on fossil fuel imports can benefit from geothermal energy by reducing their dependence on foreign energy sources and diversifying their energy portfolio. This can enhance energy security and promote a more sustainable and diversified energy future. Overall, geothermal energy presents a compelling solution for a sustainable future with its low carbon emissions, reliability, direct use applications, and potential for energy independence. As technology advances and costs decrease, Geothermal energy is poised to play a significant role in meeting our growing energy needs while minimizing environmental impacts. Thanks for watching. Don't forget to subscribe to get updates on our latest videos. And if you want to support us, you can do so through donations. Your support helps us continue producing quality content. So once again, thanks for watching, and we'll see you in our next video.